So today, the agenda, which can be changed if we need to, whatever you guys need, discuss the overview of the AP Calc exam scoring and the topic emphasis, specifically the free response. Multiple choice, I don't know. Your guess is as good as mine. All right. We talked about the exam format, but we'll also look at recognizing problem types, specifically FRQs, sample cut scores of overall tests, and when to skip questions. All right, so that's my goal. So let's start here. Have you seen this scoring worksheet? Have you seen it? Something like it? Okay, so for multiple choice, we already talked about this. You take the number correct times 1.2. Now, there's websites for this. All right, there's websites for this. Number correct times 1.2, and that's your scaled, weighted multiple choice score. And then your free response 1 through 6 are out of 9. They're not weighted at all. A point is a point. All right. The total is out of 108. So here's an example of this was the 2017 practice test. I don't think you guys have seen this 2017 practice test. I don't think so. Does anybody have a good memory and remember if we've done any part of it? So here's another option. If you're still going strong, ambitious, and you want a full-length practice test and you just want to sit down and take it now that we've done all this review, next week would be a great opportunity to do that. If you would like a copy of it or want me to assign it to you on AP Classroom, I can do that. How many of you would be interested in a full-length practice test? Okay, so here's what I'll say. Here's the score breakdown. Take a look. For a 5, 71 to 108. For a 4, 59 to 70, and so forth. So that's a lot. That's a lot to take in, right? So there's a website that makes things a little easier. There's several of these. Let's just run through a possible scenario, all right? What do you think would be a good multiple choice score? Out of 45 questions, how many would you think would be, what's your goal of getting right? 30? Okay. I'm sorry, but you're at a 1. I'm just kidding. You haven't gotten any multiple choice or free response questions, right? All right. What about 3 out of 9? 3 out of 9? See where I'm at right now? If I can get 30 out of 45 multiple choice right, and I get 3 on my first FRQ, 3 on my second, 3 on my third, I could technically get zeros on the last 3 of them and still get a 3. Okay? Is that comforting? All right, let's say we get 2s on the rest. All right, we're still at a 3. Now, let's say on one of them, we just nail it. There you go. Oh, you immature kids. All right. I should know. I've been teaching long enough. You right, Jade? You right? All right. All right. So there we are. We did really well in one of them. Okay, did really well in one of them. A little under half the points on the next one. A little under half on the next, and then 2, 2, 2. All right. But I don't know. 30 seems kind of steep, right? 22? Go for half? Whoa. All right, so let's say we get like. So here's what I'm trying to say. About half on the multiple choice. I think we can all agree there's one of those 6 FRQs that you go into and you get most of the points. Like when I say most, 5 out of 9. Okay. We won't go the Jaden route, but 5 out of 9 is, I mean, that's just over half. I mean, it's not nailing out of the ballpark. 7, and maybe a 4, and a 4, and a 4, and maybe another one you do real well on. Real well. Yeah. And then maybe bump it up to that. Obviously, there's a bunch of variables in play. All right. A lot of moving parts. What's your takeaway? So what's the take? In all seriousness, the takeaway is your standard shouldn't be, oh my gosh, I just got a question wrong, I'm going to freak out. Like that should not be the case. Like you can miss a couple in a row. Here's what I have found from my experience. Okay. And I've watched students over the years take practice tests in class and stress. I hear the conversations. Like they take the multiple choice test and like, oh my gosh, I just missed like 3. I'm going to bomb this. Like you missed 3 in a row and you think you're going to bomb it. Okay. What does this tell you? You could miss 21 of them. You could miss 21 multiple choice questions and still be okay. Please take that away. Like, do you understand that? Don't beat yourself up when you're taking the test. If you sat in there on that Wednesday morning, that late start where we all got together in hotspot A and B, and you took that test, you know it's exhausting. That was just the FRQs. Okay? The test takes a while. You have to be patient with yourself. You have to give yourself some leeway to miss some points. Okay? And we're not used to that. We're just not. You guys are used to getting 90%, 80%, whatever. I mean, 29 on multiple choice, 28 on the FRQs. Like 54 out of 108s, that's half. Do you get my point here? Okay. Just relax, take a deep breath. Now, having said that, have you heard of the expression, the low-lying fruit? Have you heard that? You're walking through an apple orchard, you're going to pick apples in the fall. Can you smell the crisp air right now? Just wonderful and relaxing. You got to get some Honey Crisps. It's the only one to grab. You don't climb to the top of the tree and grab those first. You get the lowest ones first. And then as you get those, you go up and you get the ones that maybe are a little bit harder to get. That's the approach I would take on this test. Honestly, if I were taking the multiple choice test right now, please listen carefully. If I were taking it right now, I would take it completely different than I would have when I was in high school. Here's my recommendation. Tom, would you close that for me? Here's my recommendation. When you're going through those first 30 questions, how demoralizing would it be if you knew you got the first 10 wrong that you tried? That'd be tough, right? But how encouraging would it be if, okay, pick off number 1. Number 1's always pretty easy. Okay, got that one right. Number 2, got that right. Number 3, got that right. Okay, 4 and 5, I could probably get, but it says which of the following, and it's going to take some time. I'm going to skip those, come back to them. I'm going to do number 6. I know I can do number 6. Okay, I can do 8. I can do 10. Do you see how encouraging it would be to know from your first pass, getting the easy fruit, all right, your first pass through the 30 questions, how encouraging would that be if you could get 15 of those right? Just the first pass without really even like spending a ton of time on any of them. And then your second time through to pick off some of the ones that you could do, but they're going to take a little bit of time. You with me? And then the numbers like 28, 29, and 30. What's up, Jackson? Thanks. Butchered your name. All right. 28, 29, and 30. They're going to be tough. You might not get those right, and that's okay. They may throw one of those questions on there that's like, I have never even thought of this. It's got e's and tangent inverses. I get the creeps just reading it. Okay? Like, Is it okay to not stress out about that one? It's okay, all right? So as much as we want to be perfectionists, you have to go through remembering this and being okay with missing some and move on and don't let it beat you down. Can we agree on that? Okay. So everyone has a different goal. As you look at this board, you may be like, you know what? Yeah, I got to get a 4. Or maybe you are going to get 30 out of 45. And then maybe your average. Jaden will miss some just to try to get that average. All right, so the 5, that's about what a 5 looks like. All right. So what is that? That's I didn't even realize that.
It's the magic number. That's the magic number.
There we go.
That's asking too much.
You guys are too much.
That's so unrealistic.
I get a call from the College Board. How did every one of your students get a composite score? They practiced really hard. Yeah, but they missed this one easy question, and it's like so close. So, yeah. Children. All right. You feel all right about that? All right. Next. So, cut scores, topic, emphasis. All right. Let's take a look. We've done this before. We haven't seen 2021 yet. Here's what we're going to do. It's going to be a little game. All right. I'm going to put a free response up. And you're the first person. I'm just making this up on the fly. So the first person to correctly guess the overall type of question it is. It's a free air high five. All right. Highly coveted. Air high five. Highly coveted.
COVID's gone.
Are you serious?
Yeah. Not really an air high five kind of guy.
What would you do?
Real high five.
Real?
Yeah, more COVID. We're good.
Kind of low effort for an air high five.
I'll give you a real high five. You get to decide.
That changes the game.
So let's run through some categories. What are some FRQ types that we've seen?
Approximation. Like
What kind?
rectangles.
RAM. Yeah, I like approximation. Using rectangles. What else? Trapezoids. Okay. And how do we usually see these? Tables, right? Tables. What else? When they give one of those, they usually like to ask, approximate h prime of 5, right? One of those, and then use LRM, whatever. What's the meaning of this? Yeah, those kind of get paired together. They pair nicely together, right? Another topic. Position, velocity, acceleration. They might ask for total distance traveled. They might ask for the average value. They might not say average value, they might say average velocity. What else? What method of calculus? This is a big point of emphasis I'd like to talk about tomorrow. I'd like to toss up on the board a couple FTC problems. It's been a while since we've focused on this. There's certain ways to approach them that I think are helpful, all right? And it kind of goes in trends throughout the years. There'll be like a couple years in a row where they will put a graph. Here's what I'm talking about. Okay, and they'll say like this is let's call this the G function, G, and they'll say G f prime of x equals G of x. All right, and they'll maybe give you an initial position. They'll say f of 4 equals 7. With me? All right, and maybe this is 1, and they'll ask for f of 8. F of 8 is what? Cool.
The integral of G from 1 to 8.
Integral of G from I heard 1 to 8.
4 to 8.
4 to 8. If we go from 4 to 8, isn't that going to tell us the displacement, how much position F has changed from 4 to 8? But to find out where it is, wasn't F of 4 7? So isn't this area, doesn't it need to have 7 added onto it to see where F is at 8? This is a fundamental theorem of calculus question, all right? So that's one I want to make sure we review, because that is a hard topic, right? It's not, there's a function, what's its y value, right? We got so conditioned in high school math to see a graph, be asked about that graph. Now we see a graph and are asked about an area function of that graph with another value. Like, you see how it's a lot more layers. So we need to look at that one again. That's FTC. All right, number 4, what's another topic we've seen a lot of? And you can look through your 2019 FRQs that you have out.
Rotating or turning around axis.
Good. I will put area between curves, and they like to do volume as well. Yeah, revolving a function around an area around an axis. They pair those together. What else?
Separable differential.
Yep, separable differential equations. That's using the initial value, find the particular solution. They'll usually pair those with a slope field. These are just my observations and your observations of what you've seen. Okay, as you've done multiple. This is not guaranteed to be on there. We're already up to 5. There's gonna be 6 questions. Related rates. I agree, just not in the context of how fast is the ladder sliding down the wall all the time. Like, that was when we did related rates for the first time. They build complexity onto that. They'll ask you some other stuff. What else? Rates of change just in general? L'Hopital's rule was tossed in there, right? Sometimes L'Hopital's rule could be in a lot of these different ones, just kind of tossed in. Any other topics you've observed through patterns, like you've seen it over and over and over? Cool.
Anti-differentiation using separation variability number 5.
Yeah.
Oh.
Yep. To be continued. Let's get into some of them. Because I can't tell you how, again, I've used this expression, how comforting it is. I'm going to say that. But when you get to a certain type of problem and you can at least say, I've seen this before. This is the type of question I expect to, these are the questions I expect to see within this problem. It's very helpful. All right. So we are going to go through, we're not going to solve the problems. We're just going to do a bird's eye view of what type it is. Problem recognition. I kind of expected more, Tyler.
Expected more?
Approximation. Where was the? I saw a Riemann sum, didn't I? Right, Riemann sum with 4 subintervals. Okay. Estimate f prime of 2.25. That's that number 1, right? Number 1. Overestimate, underestimate. So here's what I'll say. They will have these types of problems. That's where you're going to get your 4, 5, or 6 out of 9 points on that FRQ. Okay? Don't stress out about these. Don't stress out about those ones. Okay? Now, I'm just curious. We're just kind of jumping all over the place. I'm just curious about the scoring of it. Oh, that's kind of weird. All right, letter A was 2 points. B was 2 points. So there's your 4, and maybe you get a point or 2 from the rest. Okay? I think very doable. Good? Number 2. Who's that? Yeah, you're not getting another one. Total distance traveled, part D. Acceleration. Explain your reasoning. Okay? So we're not going to solve this one. Are particles P and Q moving toward each other or away from each other at t equals 1? How would you explain your reasoning on that? Cole?
You use the sign of the velocity function at t equals 1. And then if they're opposite, that means they'd be moving toward each other.
Yeah, because one's moving to the right, one's moving to the if you say opposite.
Yeah.
So one's moving to the right, one's moving to the left. And you'd have to also kind of know where they are, their position, correct? The particles are moving toward each other because particle Q is at position blank, P is at position blank, and their velocities are opposite. That would be a great explanation. All right. Next. Just a reminder, the first 2 are calculator active. Yes, Tyler.
I'm curious. So if they were, let's say one's at position of 8 and one's at position of 5, but the one in position 8 is has a negative speed. That's
Hold on a second. One's at 5.
Yeah.
One's at 8. Let's call this particle P, particle Q. Go ahead.
So let's say.
What did I do?
What
are you gonna do? 2 different numbers. Okay.
Was that so the one at 8's velocity is negative, but it's a greater negative. It's more negative than the one at 5. Would they be considered what would you say, moving toward or away?
So this one is what?
That one's negative, but less negative than the velocity of the other one.
So this one's moving. But they're not moving toward each other.
But they're still getting closer to. Is it not?
They're getting closer together, but they're not moving toward each other. Do you interpret it that way? Toward each other, I'd say are let's say, hey, let's walk toward each other, and you start going that way, and I'm creepily getting I'm going towards you, but you're not coming towards me, right? Would you agree with that? I mean, from your experience asking a girl out or anything? Okay. Sorry, I didn't mean to go.
Whatever the one is, area between curves.
Area. Is there any revolution in that one? Now here's the deal. Like you might like be happy and say, oh, they did like an area between two curves, top minus bottom or right minus left or whatever, and then they throw a stinking constant, some other random constant in there that's like it's confusing. All right, don't get frustrated by that. Just break it down into what you know. All right, find the area of the region, graph of CX for C equals 6. So they even said for part A, C equals 6. All right, so 6x radical 4 minus x squared. Next one. I haven't heard anyone yet. Your high five or real high five? That was better than Tyler's, by the way. Fundamental theorem of calculus. Just kidding, Tyler. All right, this is F. G is the area under F. I honestly have not read this yet. Okay. My first thing in my mind I'm thinking of, are they going to give me some position on F? Do they call it F? No, on G. Are they going to give me some position on G? Because if so, they're either going to ask me what is the displacement on this part of it, or do you agree if they just ask for what's the displacement from here to here, I don't care where the particle started. But if they say where is the particle at this time, I need to know how far it moved and where it started. You with me? So in my mind, I'm looking for that. So I read the problem. All right, boom, boom, boom. I don't see any sort of position on F. Do you agree? Unless they tell me down here somewhere else. But I'm telling you right now, look for it. They may not give you that information, but look, or like this one, they did not give you that information, but sometimes they do. All right? And look, what am I expecting for part C? L'Hopital's rule. Now, could they make it some easy limit problem where it's just a number? Yeah, but they're not usually that nice. Let's see. I told you I wasn't going to do this problem, but I probably am. All right. Integral from 0 to 2. Look at 0 to 2. What do you notice? What's the integral going to be from 0 to 2 without doing any math? 0. So the integral from 0 to 2 on G is 0. So the limit as x goes to 2 is G of 2, which is 0 over, yeah, they went there, 0 over 0, L'Hopital's rule. G prime of 2 over 2x minus 2. What's G prime of 2? How'd you get that, Cole? You're right.
Just that slope from 0 to 2.
Hold on a second. G prime of 2 equals f of 2. Do you agree? If I take the derivative of G, you have to take the derivative of that. Right? L'Hopital's rule, G prime over 2x minus 2. You with me? How do I get G prime of 2? Well, I look at the graph and I take f of 2. What's f of 2? F of 2 is negative 4. You see it? You see it?
For this question, could you say that the graph of f is the derivative from g of x?
It is. Yep. Yep. G prime of x equals f of x. That's exactly what I used here. G prime of 2 equals f of 2. You with me? FTC. All right. Then we also talk about this average rate of change of G from -4 to 2. I'm breaking my promises. I wasn't going to do these problems. Stop.
So since g of x is just some 0 to x, so if x is negative, f of t won't be the derivative of g then?
It will.
It still will be?
Yep.
Okay.
It'll work itself out. So if I want to find G prime of -2, it's f prime of negative. It's f of -2. All right. And then does the mean value theorem guarantee a value for which G prime is equal to the average rate of change? Mean value theorem. All right. That's not going to be a main topic, but it could be a sub topic in there. 5. Air high five, or high five, or none of the above. First derivative test. What's the main topic, though? There's a first derivative test within it. What's the main topic? Do you remember what that's called? Extremas. Yep, same thing as first derivative test. Cole?
Is that not anti-differentiation by separation of variables?
It's not. Implicit differentiation. Implicit differentiation. If you're looking for a video to go back and review, this is probably another one of them. This is one of those, you look at this function, you say, I cannot solve for y. I'm going to have to take the derivative as it is. So any term with a y in it is a chain rule, because y is a function of x. Right? Remember that? So what's the derivative of 2y squared? 4y times dy dx. Remember that? Minus 0, so just 0, equals, what rule do we use for y times sine of x? Product rule. Y times cosine x plus sine of x times dy dx. Collect all the dy dx's on one side, factor it out, solve. So when they say show that, that means use implicit differentiation and solve for dy dx. You with me? All right. And then they're going to ask some questions about it. Real?
Yeah.
Separable differential equations? Were you looking at my elbow?
Yeah.
Thank you. All right. Slope field? See it? Slope field? And then boom. Use separation of variables to find a of t, the particular solution. All right. We guessed it, didn't we? We did pretty well on that one. Before we even started, we listed those 8 topics. Let's go through another year. This is fun. 2020 is not a good representation. I don't know if I actually downloaded it. Did I? What is going? Oh, there we go. Nah, this isn't the real test. I don't know if they even released that one. We did 2019. Let's go through this one quickly. We did this. I'm just as an example, guys. We're not solving this. Just problem recognition.
Yeah.
Or
Or
division.
I'm gonna write it as a subtopic of rates of change. Do you agree you might have amount entering, amount leaving? Is that what you meant when you said rates of change?
Yeah.
Okay. So rate entering, rate leaving. Let's just call them E of t and L of t. I think there was that one example that we did that. Was it even this one? No. All right. Rates of change, I would also call this the integral as a net change. This is a big topic on the AP curriculum. The integral as a net change, meaning if you have a rate and you find the integral of that rate, you get the net change. We call it displacement if it's in the context of velocity. But net change, like if I have, fish per hour entering is this rate, and if I find the integral of that, I get how many fish have entered. Get the integral as a net change of fish, right? That's what that's called.
Good. Next one. Good. Position, velocity, acceleration, total distance travel. Next one. Who was it? Jaden? Thank you. This is kind of a mashup. It's kind of FTC and first derivative test, second derivative test, isn't it? Sorry, I took away the excitement on that one. Approximation, number one. Anyone? I mean, I see some extrema. This was this one's a lot, kind of a random hodgepodge. There you go, hodgepodge of topics. Separable differential equation. And there is that year. One more.
97.
Last one. Rates of change. Yep. Do you guys see how many cubic feet of rainwater flow into the pipe? Amount of water in the pipe? Minimum. They like to kind of combine those topics. Number two. Area between two curves. Volume. Approximation. What do we see when we see absolute value of V of t? Total distance traveled. Bob's just cruising on his bicycle here. You're going to get tricked here. You're going to get tricked.
It's a sketch of slope field and slope field.
Yeah, it's separable.
Are these separable?
Yeah.
Back when we did section 6.4, we defined a separable differential equation as being in the form dy dx equals f of x times g of y. A function of x times a function of y. Because then you can separate them. You can divide, you can multiply. Yes? See the subtraction there? And it's okay. Letter B. Slope field. Letter B. Find the second derivative. Don't get trapped. You don't get tricked here. Take the second derivative. 2 minus dy dx. And what's dy dx? 2x minus y. Inception.
That might get me.
All right.
That's 4, 5. What do you think? It's the overarching, I would say, is first and second derivative tests. Do you see how letter A, relative max? Now, I do want to pause on this one. Here's why. I have seen what I call the visual first derivative test all over. Okay? Visual first derivative test. They don't want to test your algebra as much as they want to test your calculus. So do you remember some of the times we would take the derivative set equal to 0, get critical points, find out where f prime didn't exist, get those critical points, put them all in a number line test? You're not going to be doing that very often. Okay? Here's how they cut to the chase. Do you agree? If we're looking for where f has relative maximum values, we would look to f prime. Tell me about f prime. For f to have a max, f prime changes from positive to negative. Oh, good. I have the graph of f prime. Positive to negative, critical point. Negative to negative, no critical point. That's it, right? And the second thing I would need to consider are endpoints. Well, let me see if what's happening if f prime is positive? Yeah, do you agree f is increasing from -3 to -2? Be careful. It's been a while since we've done this. Don't let your eyes deceive you. F is increasing from -3 to -2. We're not looking at the graph of f, right? But it's increasing. You with me? Then f decreases for a while. What happens at 1? Yeah, it was decreasing, and then it kept decreasing, right? And then it keeps decreasing until 4. All right? -2 is your critical point. And it's a max. Give a reason for your answer. Practice, practice, practice. Don't shortchange this. Please, who can raise their hand and give me a good answer for why x equals -2 is where f has a relative max? I'm going to warn you, don't use words like it. Go ahead.
X equals -2, the derivative of f changes from positive to negative.
Therefore,
it's relative maximum at -2.
Therefore, f has a relative max at x equals -2. Good. Yep. Perfect. Make sure you name the functions. F has a relative max at x equals -2 because f prime changes from positive to negative. Done. All right.
Concave down, we'd be looking for where f double prime is negative. What's f double prime?
The slopes of this thing. Right?
Good. Or in other words, where this thing is decreasing, right? All right, last one for today. Implicit differentiation for part C at least, right?
Take the derivative of that thing. So everybody pause. How do we feel about this? Pretty comprehensive? Okay, now, is it possible a subtopic in one of these is off the wall and you have no idea what to do? Yeah, moral of the story today though, it's okay. Let it go. All right, you can try it, but don't stress out about it. All right?
Did I cover everything we want to talk about?
Tomorrow. Tomorrow's a big day. Big day. Big day.